Hi everyone. Today I want to discuss with you what a class any is and which methods it has and their default implementations. So let's go straight to the documentation and read this sentence. Every Kotlin class has any, it's the name of the class, as a superclass. So it means every class inherits any, directly or indirectly, but it is what it is. So what does it mean? I declared a user class. It's a simple class, has two fields, name and age. And according what we've just read, it means it inherits any class. But we didn't write it, right? So let's check it. Let's create a user instance. Like, let's say his name is Alex and age, I don't know, 69. Alex is quite old. And we want to create another variable is user class any, let's say. And here we're gonna check if the user is an instance of class any. And we also want to print the message like this. Let's run it. Yeah, and you can see I didn't lie to you. It prints true. So this part of code, like user inherits any, it's still available on runtime, but it's done by a compiler, so we don't need to write it, just to be aware of it. So let's check what any class has. It has a simple empty constructor, nothing interesting here, and three methods: equals, hashCode, and toString. So let's go deeper at each of them. The method equals basically needs to understand if two objects are equal to each other or not. hashCode returns a hashCode value for the object. It's usually needed for object when you use them in some of collections, but we will discuss it later. And toString method, just a string representation of the object. So let's check what are their default implementations. For example, we can print hashCode. Let's run it. What is this? It's an integer, and we didn't overwrite hashCode in user class, so it means now we are using the default implementation from any class. And the default implementation from any class, it's an address in the memory of this object, particular object. So if we create another object. Let's say it's user1, now it's user2. This one we don't need. And let's change the name, for example, and age. Run it. The first one still has the same hashcode, and let's, for example, print for the second one. You see the hashcode is different because it's a different object, different instance for the user class, and it has different address in the memory. So that's why they're different. But another interesting part, if we create at first glance the same object and run it again, as you can see, it still has different hash codes. Because again, default implementation, it's all about address in memory. And these two objects, they're different instances of the same class. So that's why they're different. And if we return to the equals method, and let's say print whether user1 equals user2. Actually, when we write two equal signs, it means the same if we write like this. Equals user2. So these two lines are totally the same. And you can see it produces two false. It means these two objects are not equal. And at first glance, why? So the name is the same, the age is the same, but default implementation of equals, it's the same if we write like this. It still will be false, of course. 3 equal signs means whether two instances are the same or not. So right now they are not the same. User1 it's one instance, user2 it's another instance. They are different. You can see they have different hash codes. It means in this case they have different addresses in the memory. But if we do something like that, now references are the same instances. And we can see now when I'm running this new code, it returns true because the instances are the same. And the last one, but believe me, you will use it a lot, especially when you override it. It's the method toString. So user1, we can write it implicitly like I did now. Let's just remove this one, run it again. Yeah, what we have, user2 we also don't need. run it again. So the presentation of toString, again, by default, we inherited this behavior from any class, and by default it has the name of the class, in our case user, @sign, and hexadecimal representation of hashCode. If you don't understand what hexadecimal, don't worry, now we don't need this information, but it's still hashCode but in special format. And I almost forgot that by default, when we use the string in this format, we can omit it and it will still work and produces the right representation of the string. Just a convenient way. Again, the compiler does all the work for us. And of course, this representation is not beautiful and the most important, not meaningful. So what we can do, we can override method toString like we want. For example, let's say the name is name, and the age is age. And when we run it, we can see the beautiful string which has much more information at least for us humans than it was before. Of course, we can override hashCode and equals as well, but to keep this video shorter, I'm gonna stop here. So hopefully today you understood basic information about any class and which method it has. And in the future, I want to talk more about equals and hashCode, how we can override them, why do we need this, and what is the relation between equals and hashCode. It really matters, especially when we want to use it in some collections like hashmap. So thank you for your attention and see you later. Bye bye.